We want to compute the following integral I. Now the main challenge here is to find a convenient substitution. And since we are seeing square root of x or x to the power 1/2, we may think of the substitution u equals square root of x. Now we're all set to apply this substitution, and our integral I becomes... Now this is still not very clear, and since we are seeing square root of u, we may think of applying the substitution v equals square root of u. So instead of doing this, which means applying the substitution u equals square root of x, then v equals square root of u, let's apply from the beginning v equals square root of x, which means v equals x to the power 1/4. So let's consider the substitution v, or h of x, is x to the power 1/4, and I'm going to explain why the substitution makes sense from the beginning. Now this substitution gives so here we can actually see that considering the substitution v equals x to the power 1/4 is convenient because it allows us to get rid of the two rational exponents of x, and then we have a rational function to integrate, and we know how to deal with integrals of rational functions. So the very first step would be the long division of v to the power 5 by 1 plus v to the power 3, since the degree of the numerator is greater than the degree of the denominator. Now after the long division, our integral I becomes... So the first part here is straightforward, and the second part is easy to handle because this function is of the form f prime of v over f of v up to a multiplicative factor, where f of v is 1 plus v to the power 3, so it will give us a natural logarithm. And the final answer would be 4/3 8 minus 1 minus 4/3 ln 9 minus ln 2, which can be written as 4/3 times 7 minus ln 9/2.